There it is. Okay. All right. Okay, so we got a 150 kilogram moose being walked. So we've got another leash problem. So at some angle. So we've got a force applied at some angle. Theta is 52 degrees. Okay, and then we've got all of our other forces. So we've got a force of friction. It's being walked and moved horizontally on a sidewalk. So that means our force of gravity should equal our force normal. So that's our FBD. That's your first part. Drawing the FBD. Next part, we're going to find the acceleration of the moose horizontally and then the normal force acting on the moose. So first we want to get the components of FA. So again, if we zoom into the FA vector, we've got an FA of 120 newtons. So we have an FAX here. And an FAY here. With an angle of 52 degrees here. So cosine is connected to x. Cosine is connected to x, so my FAX is going to equal my vector 120 times cosine of 52. Cosine of 52 times 120. Okay, so a little shorter than SOHCAHTOA, right? A little shorter than SOHCAHTOA. But this basically is SOHCAHTOA. So it's still good to know that SOHCAHTOA is the reason why we can do this. But when you're solving for components, it's just a fact that sine relates to your vertical component and cosine relates to your horizontal component. So FAY equals 120 times sine of 52. All right. By the way, little trick you can mentally check if you did these right. If I have an angle that's greater than 45, then you should have a greater y component than your x component. If you have an angle that's less than 45, then your x component should be greater, because 45 is the middle of 90, right? 45 is that middle point between 90. So if we're below 45, your x component will be larger. If you're above 45, your y component will be larger. Just a little check you can do there. And if they're at 45, then the x and the y equal each other. Reed, you sure you're good? Do you want to get some water?
No, water's not gonna help.
Water's for losers.
It's not because my throat is dry.
Okay. So given we got our mass of the moose, 150 kilograms. We've got our force applied, 120 newtons. We've got our FAX and our FAY. Hope you guys aren't talking trash about anybody because it's recording, so I can hear your conversation.
Is this for
What? This is for B, yes. Yeah, A was just to draw these FPDs. I think so. Reed. I think it'll pick it up. All right, and then the force of friction, we've got FF is 11.55. We gotta hurry up a little bit here. And we're trying to find right here, we're trying to find the acceleration net in the x direction, the net acceleration. Okay, and then my equation will be my F net in the x direction. The only forces happening in the x direction are force of friction and the force applied in the x direction, so FAX. I know FAX is going to be greater, so I'm going to make it positive. FAX minus FF, so force of friction is negative. Then I do MA net in the x equals FAX minus F of F. And then I'm solving for I'm solving for A net there. So I'm solving for this one. I have the mass of the moose. I have my force applied component. And then they give me force of friction. So I have everything. Okay, so we do 150 kilograms times A net equals 73.88 newtons minus 11.5 newtons. Do 73 minus 11, so I get 62.33 equals 150 times A. I divide 150 on both sides. So our acceleration in the x direction is 0.42 meters per second squared. Okay, the next question is interesting. It's a fun question. Next one says, what's the normal force acting on the moose? The normal force. So solve for the normal force. Very interesting. It's on the setup. First of all, any questions about what we just did? Okay, practice makes better, you guys. Practice makes better. Make sure you do these problems. I'll put the answers on Canvas. There's going to be 2 more up until page 9 that have the angle problems. There's 2 more that we've skipped that you'll have to do. Okay, so find the normal force. So let's write the equation. So we just wrote an equation in the x direction. What would the equation be in the y direction? Well, just to draw again, what we've got in the y direction, so our FBD in the y direction has gravity going down, Fg, and then we have 2 things going up. We have the FAY, because he's pulling at an angle upward, right? So it has an upward force. So we have FAY, and we also have force normal going up, and we don't know how much that is. But we can solve for the weight of the moose because we have the mass, and then we solved for FAY earlier, the component, so we should be able to solve for force normal. So, and then also we want to realize that the net force in the y direction, the moose is not going up at all, so the F net in the y direction is 0. Does that make sense? The moose is not going up or down, not accelerating vertically. So that means all the forces are canceling out vertically. The other thing is that, so F net, so if this is 0, that means all the opposing forces have to equal each other. So you can kind of do this 2 ways. You can say that Fg has to equal Fn plus Fay. Does that make sense? If F net in the y is 0, then these have to equal each other. Both sides have to equal each other. So Fg equals Fn plus Fay. You could do it like this, or you could say that, well, I know that F net in the y equals, and you would make one of these negative and the others positive. Let's actually try it the first way first. Okay, so Fg equals Fn plus Fay. And then we solve for Fn because we can, I guess we haven't done Fg yet because we have mass but not Fg. But we can get Fg by using the acceleration due to gravity. We have the mass. Once again, guys, if you're on Earth and they give you the mass, you can solve for the weight. If they give you the weight, you can solve for the mass if we're on Earth because it's F equals ma and you have A. So we have Fg, we'll solve for Fg, and then we have Fy, so we'll be able to solve for Fn. So the force due to gravity, quietly pack up, please. You can quietly pack up this video. Let me finish the video. Fg is going to equal the mass 150 times 10. So Fg equals 1500 newtons, the weight of my moose. Okay, then I'm going to use this formula and I'm going to do 1500 newtons equals Fn plus Fay we solved for was 94.56. So then I just subtract the 94 over there. It would be positive.
That means when you're busy. No, Jesus Christ. They don't say this. Should I put this in my folder?
Yeah, keep that in your binder. Yeah, keep your quizzes and your tests. Yeah. Bye.
Have a good weekend.
You too.
Have a great weekend.
You too.
Sir, I have a question in my quiz. That in the first one, why is 14 with zeros?
Oh, comma.
Le-
So you've got, yeah, just be careful with, because I know where you're from, you use commas for periods for commas, and comma, it's backwards, right?
yeah.
So just be careful with that, because now we use commas for periods. So this one should be a comma, right?
Mm-hmm.
And so this, I understand kind of what you would think this is. You are converting it to a kilogram, right?
Yeah.
But Newton's already uses kilograms.
Oh.
Okay, so a Newton is a kilogram meter per second squared. Same thing. Okay, so kilogram is already in a Newton. You don't need to convert it.
Oh, okay.
Okay, it's kind of different because mass is the only one that uses a prefix, because we don't use kilometer or kilosecond or microsecond, but for the standard unit is a kilogram, not a gram. So
Okay.
it's a little different like that. Okay.
Okay, thank you, Mr.